Good morning all. This is Dr. T. Khalandar Basha, working as Associate Professor in Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today I am going to discuss the logical design of IOT under the course Principles of IOT. The slides are prepared by referring the textbook Internet of Things, a hands-on approach, authors by Ashdi Baga and Vijay Matsetti, publication Universities Press. So in this session, we will discuss the logical design of IOT, under which we are going to see the various IOT functional blocks, IOT communicational models, IOT communication APIs. So the logical design of an IOT system refers to an abstract representation of the entities and process without going to the lower level specifications in the implementation. So for understanding the logical design of IOT, we will see the few terms corresponding to it. They are IOT functional blocks, IOT communication models, and IOT communication APIs. So the IOT functional blocks, mainly it is consist of a number of functional blocks as shown in the figure that provides the system the capabilities for identification, sensing, actuation, communication, and management. So this is the application level where we can have the security, services, communication, and management. And this application can be interacted with the device, or device can be interacted with the applications by means of these functional blocks. Now we will see in detail description of each and every block of logical design of IOT. So the IOT functional blocks are described as follows. The first one is a device. So an IOT system comprises of devices that provides a sensing or actuating or monitoring and control function. So if the device acting as a input device, it will sense the few physical parameters that can be given to the application. If the device is a output device like an actuator, then the commands will be received from the applications. Similarly, if you are monitoring by sensing the input devices for monitoring the data, or we can have some control on the devices. So the communication, it is handles the communication for the IOT system. So services, the services in IOT system uses various kind of services such as device monitoring, device control services, and data publication services and discovery services for the devices. So management, so it provides the various functions to govern the IOT system. Security, so security functional blocks mainly secures the IOT system and by providing functions such as authentication, authorization, message and content integrity and data security. So the application, so IOT application provide an interface that the end user can use to control the input devices, as well as they can monitor the input devices, or they can allow for controlling the devices which are of output devices. So application allows user to view the system status and view or analyze the processed data. In the IOT communication models, the next topic in the logical design of IOT is communication models. So in IoT logical model, the various communication models we can have is a request and a response, publish and subscribe, push and pull, exclusive pair. So we will say in detail description of each and every communication model. So in request response model, it is a communication model in which the client sends the request to the server, and the server, after taking the request, it will give a response whoever given the request, which is nothing but client. So when the server receives a request, it decides how to respond and fetches the data, retrieves the sources, that is a resource representation, prepares the response, and then send back the response to the client. So this request response model is a stateless communication model, and each request response pair is independent of each other. So the client can have multiple requests, server can be given a response to a particular kind of request also. So the next slide will give the figures where the client server interaction through the request response model. So from the client, a request is given to the server. So this server receives the request which are from the clients, and they will be processed. Request looks up, fetches the resources, prepares the response, and send it back to the clients. So for client, they can send the request to the server. What are the requests which are received by the server? It will be processed the request, and whatever the resources are required, they will prepare, and accordingly response will be prepared and send back the response to client. Publish and subscribe. The second communication model is publish and subscribe. So publish subscribe is a communication models that involves publishers, brokers, and consumers. So publishers are the sources of data. So publishers are not aware of the consumers. Publisher sends the data to the topics which are managed by the broker. So consumers subscribe to the topics which are managed by the broker. So when the broker receives the data for a topic from the publisher, it sends the data to all the subscribed consumers. So now here the publisher, they will send the messages on various topics. So messages published to topic 1, message published to topic 2, like this. In your topic 1, we may have multiple consumers. For topic 2 also, we may have consumers. So in this example, the topic 1 is subscribed by consumer 1 and consumer 2. Similarly, for the topic 2, which is subscribed by consumer 3. So this figure shows the publisher, and middle one is a broker, and consumer interaction in the publish subscribe model. Next one is push pull. Push pull is a communication model in which the data producers push the data to the queues, and the consumers will pull the data from the queues. So producers do not need to be aware of the consumers who are pulling the data. Queues helps in decoupling the message between the producer and the consumer. So queues also act as buffer, which helps in situations where there is a mismatch between the rate at which the producer is pushing the data and the rate at which the consumer is pulling the data. So in the push-pull model, the publisher will send the message to the queues, whereas the consumers will pull the messages from the queues. So in this case, the consumer 1 is pulling the data from the Q1, whereas consumer 2 is pulling the data from another queue, which are published by the publisher. The next communication model is exclusive pair. Exclusive pair is a bidirectional full duplex communication model that uses a persistence connection between the client and server. So once the connection is established or it is set up, it remains open until the client send a request to close the connection. So client and server can send messages to each other once the connection is established. So exclusive pair is a stateful communication model and the server is aware of all the open connections. So in client server interactions in the exclusive pair model is shown in the figure. So here for set up a connection, first client give a request for the server to set up a connection. Then the server will accept the request and it will send the response for accepting the request ready to set up connection. So once the connection is set up, then the client will send the messages to the server. So upon receiving the messages from the client, the server will use the response message to the client. So once the data transaction is done, then the client will give a close request for the given a request. Then the server will use the acknowledgement kind of thing for closing the response. The third topic we can see under logic design of IoT is IoT communication APIs. So in this communication APIs, we have mainly two types of communication APIs. One is REST-based communication API. The second one is WebSocket-based communication API. So under REST case, we have client-server model, stateless, cacheable, layered system, uniform interest, code on demand. Now we will see a REST-based communication API, where REST stands for Representational State Transfer. So REST is a set of architectural principles by which web services and web IPS can be designed that focus on system resources and how resources states are addressed and transferred. REST APIs follows the request-response communication model. The REST architecture consists of apply to the components, connectors, and data elements within a distributed hypermedia system. The REST architecture contains as follows: client server, stateless, cacheable, layered system, uniform interface, and code on demand. Now we'll see a client server in the REST API. So the principle behind the client server constraint is to a separation of the concerns. For example, client should not be concerned with the storage of the data, which is concern of the server. Similarly, the server should not be concerned about the user interface, which is a concern of the client. So separation allowed for client and server to be independently developed and updated. Next one is stateless. So each request from the client to the server must maintain all the information necessary to understand the request and cannot take the advantage of any stored context on the server. So the session state is kept entirely on the client. Cacheable. Cache constraint requires that the data within a response to a request be implicitly or explicitly labeled as cacheable or non-cacheable. If a response is cacheable, then the client cache is given the right to reuse that response data for later or equivalent request. In caching, can be partially or completely eliminate some iterations and improve efficiency and scalability because of existing already, and which we can go for reuse. Layered system. Layered system constrains the behavior of component such that component cannot see beyond the intermediate layer with which they are interfacing. For example, a client cannot tell whether it is connected directly to the end server or to the intermediary along the way. So system scalability can be improved by allowing intermediaries to respond the request instead of end servers without the client having to do anything different. Next, we'll see uniform interface. So, uniform interface constraint requires that the method of communication between a client and server must be uniform. So, resources are identified by the request like URIs and are themselves separate from the representation of the resources that are returned to the client. So when a client holds a representation of a resource, it has all the information required to update or delete the resource. So each message includes enough information to describe how to process the message. Next, code and demand. Servers can provide executable code or scripts for the clients to execute in their context. This constraint is the only one that is optional. Now we will see in REST-based communication APIs, where it is for communication established between the client and the server using REST APIs. So here, a REST aware HTTP client, they will give the HTTP packets by using the methods get, put, post and delete. Whereas REST payload, either it can be JSON or XML format. Then the data will be sent to the server. Here in the server, it will check for authorization as well as web services. So this server will get the required data from the resources, where URIs will have the representations and resources. In this, client and server are communication with REST APIs. First, client will give a request with the payload. Here the request can be a get, put, update or delete. Whereas the payload, either it may be JSON or XML. Then the server will give a request on JSON and XML. Again, here the client can have one more request like get, put, update or delete with a payload JSON or XML. Then the server will give the request on JSON and XML. So RESTful web services is a collection of resources which are represented by URIs, where URI is Uniform Resource Identifier. RESTful Web API has basic URI like HTTP, some example.com/API/task. The RESTful web service can support the various internet media types, JSON being the most popular media type, and RESTful web services. IP for Smart Object Alliance, that is IPSO Alliance, had published an application framework that identify the RESTful design for use IP Smart Object System. Now the client send the request to the URIs using the methods defined by HTTP protocol. So first we will come across get method, then move to put, post and delete. So the HTTP method is get method. The resource type is collection URI. Either the resources can be a collection URI or element URI. So in the collection URI, it will list all the resources in the collection. Whereas element URI will use the information about a particular resource only. So the web link for HTTP model for get you can have is example.com/API/task, where we are not specified what is the task. So it is going to list all the tasks. When it comes to get method for element URI, we are going to be mention what is the task. So this URI will give the information on task 1 only. The next methods we have is post method. So in the post method also we have two types. One is collection URI and element URI. So this will create a new resource like http://html.com/API/task. This is for creating a new task for the data provided in the request. Whereas element URI, generally it will not be used. So that's why we have not mentioned any example. The next type of HTTP protocol we can have is put. The put also you can have collection URI or element URI. In the put, it will replace the entire collection with the another collection. Whereas put for element URI, it will update only a particular resource. Example we can have is example.com/API/task. So this will give replace the entire collection of the data provided in the request. If a given as a particular task, it is going to replace or update only particular task, that is task 1 in the example with the data provided in the request. The next HTTP protocol we can have is, that is HTTP method is delete, where the delete can be collection URI or element URI. This delete method, it is used for deleting the resources. If you are using collection URI, it will delete the entire collection. If it is element URI, it is going to delete a particular resource. Example, http example.com/API/task. So where it is going to delete all the tasks which will be there in the request. Whereas in element type, we are going to be mentioned which particular task we want to delete. The next type of communication APIs we are having is WebSocket based communication APIs. So WebSocket APIs allows bidirectional full duplex communication between clients and server. Unlike a request or response APIs such as a REST, the WebSocket APIs allows a full duplex communication and do not require any new connection to be set up for each message to be sent. So at a time, both client can send or transfer, communicate with the server. Similarly, server can communicate with the client. So WebSocket communication begins with a connection setup request sent by the client to the server. This WebSocket handshake request is sent over HTTP and the server interprets it an upgrade request. So in the WebSocket protocol, the client and server will be communicated first by establishing the connection with a request from the client to the server. So once the connection is established, it is for initial handshake over the HTTP. Then it will give a response for accepting the request from the client by the server. Then the data frame exchange will be takes place between the client and server, where this data frame is a full duplex bidirectional communication. That means both the data frames can exchange between the client and server at the same instant. So once the data transaction is done, then we go for closing the request. So now the client will give us connection close request. So now the server will take the request and closes the connection. So if the server supports WebSocket protocol, the server responds to the WebSocket handshake response. So after the connection is set up, the client and server can send the messages or data to each other in a full duplex mode. WebSocket API reduces the network traffic and latency as there is no overload for connection setup and termination request for each and every message. WebSocket is suitable for IoT applications that have low latency and high throughput requirements. So now we will see the comparison between REST and WebSocket APIs. First, stateless and stateful. A REST service is a stateless in nature. Each request contains all the information needed to be processed. Requests are independent of each other. Whereas in WebSocket is a stateful nature where the server is going to be maintain the state and is aware of all the open connections. Unidirectional and bidirectional. REST service operate over HTTP or unidirectional, whereas request is always sent by a client and the server respond to the request. So WebSocket is a bidirectional protocol and allows both client and server to send the messages to each other. Next, request response or full duplex. REST services follow a request response communication model where the client send a request to the server and server responds to the client request. Whereas in WebSocket, it will allow the full duplex communication between the client and server. That is, both client and server can send the messages or to each other independently. Next, TCP connections. For REST services, each HTTP request involves setting up a new TCP connection. WebSocket, on the other hand, involves a single TCP connection over which the client and server communicate in a full duplex mode. Header overhead. REST services operate over HTTP and each request is independent of others. Thus, each request carry HTTP headers, which is a overhead. Due to the overhead of HTTP, REST is not suitable for real-time applications. Whereas, on the other hand, WebSocket involves no overheads of the heads. After the initial handshake for establishing the connection that happens over HTTP, the client and server exchange messages with minimal frame information. Thus, WebSocket is suitable for real-time applications. Scalability. Scalability is easier in case of REST. services as a request are independent and no state information need to be maintained by the server. Thus, both horizontal, that is scaling out, and vertical scaling, that is scaling up solutions are possible in REST services. For WebSocket, horizontal scaling can be cumbersome due to the stateful nature of the communication. Since the server maintains a state of connection, the vertical scaling is easier for socket than horizontal scaling. So in this, we have discussed the logic design involved in IoT, the various functional blocks, communications, and communication APIs. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.